Hello again. This is Math 1115 and it's part of a post-spring break era of COVID-19 reset. In Blackboard you will find that grades are posted, and going forward you should realize that in this era accommodations abound. I don't want to write this down, but I think you should realize that in many ways this might be your best chance to get this requirement completed by staying the course this term. You want to think about that as you go forward, but I think there's a lot of truth there. The quiz over Chapter 2 content will be covered on the final exam. Only about a half a dozen of you took the quiz before you ran into big lines at the testing center. I was planning on grading those, but then allowing people to make that up. But that's not going to happen because we're not really going to reconvene in the same way this term. And so what I'm going to do is I will explain how I'm going to count this, but the content will be revisited on the final exam. And there will be a final exam online during the final exam period. That is a change of plans because we're not going to be coming back to campus during this spring 2020 term. And this final exam will count for 1/3 of your grade as originally planned. So I encourage you to not only stay the course but engage so that you'll be able to do well on that exam. Quiz 2 will count as extra credit for those who took it. And this is the solution overview. The reset is continued in other videos, but I really wanted to use this as an opportunity to think about my wife. My wife was quite a quilter when she was alive, and this was one of her mottos. She made quilts like this. In fact, this is a quilt she made. When life gives you scraps, make quilts. That's what we're doing this term. Learning is still very possible for you, and John and I will teach you a good course. Grades can be earned and rendered, and your goal. So this is the Chapter 2 quiz, and you will see this material again on the final, so pay heed to it. First problem was considering this figure. They told you that AB, this line here, was parallel to the other line. You were supposed to consider the figure and complete the table. And we knew that this angle here was 148 degrees. So angle CGE, which is this angle up here, is on the same side of the transversal, so that's going to be supplementary to this angle. So that's going to be 32 degrees. AFG is 90 degrees because we see that little symbol there. It's DGH. DGH is a vertical angle with this one that we already figured out what it was, so it also has to be 32 degrees. EGI is going to be this 32 degrees added to that 90 degrees, and that makes it 122 degrees. And CGH is also 32 degrees added to 90, so it is also 122. Those were 2 each. Here we consider the following figure, and CT, this line segment over here, this line I guess over here, is tangent to the circle of center O, and the measure of arc AB, this is arc AB, was 50 degrees. Complete the table. So you want to know what is the measure of angle BTA. BTA, that is an interior angle, so it measure is 1/2 the measure of the intercepted arc. The intercepted arc is 50 degrees, so that's going to be 25. BTC. BTC is this angle right here. And let's see, we know that the tangent to a circle is perpendicular at its point of tangency, so that means this is a 90-degree angle. So this is going to be the complement of this 25-degree angle, so that is 65 degrees. TAB. TAB. Now TAB, this is again an interior angle. It's 1/2 the measure of the intercepted arc. But this entire arc here is 180 degrees, and this is 50. That means that's 130. So this is 1/2 of 130, or 65. ABT. A, B, and T. Well, you can realize that this forms a triangle, and these two end up being complementary. So that means that this is a 90-degree angle. Another way to have derived that was that this is an interior angle that intercepts an arc of 180 degrees on the circle. So it measures 1/2 of that. So that is 90. And BOT, BOT is this angle. I told you had to draw that. And that's a central angle whose measure is exactly the intercepted arc. And so it's going to be 130. Number 3, a person's eyes were 160 meters above the ground at point A, and a mirror is placed there. They look down and they look up. From physics, you know that the measure of angle 1 and the measure of angle 2 are the same. So if the distance AM is 120 centimeters, you want to make sure that you're thinking about the units. And the measure from B to M is 4.5 meters. Find the height. Well, these are similar triangles. So what you say is that the 160 is to the 120 as x is to 4.5, and you get x is 6. Now your answer to be completely correct had to be 6 meters. We have to get our units correct where they're provided. Number 4, we have a rectangular soccer field whose width is 70 yards, but it has a 130-yard diagonal. What's the perimeter of the field? That's the distance around. Well, you need to find the missing dimension. You need to think about this as a right triangle. This is going to be the hypotenuse. So the remaining side is going to be c squared minus a squared. And we get this, but if you turn that into a decimal, you'll get 110. Call it 110. That means that two sides are 110, and the other side is 70. Other two sides are 70, so that is 360, and the units should be yards. I also ask you what was the area of the field, and that's going to be length times width, and the answer there would be 7,700 square yards. The Bermuda Triangle is sometimes defined as an equilateral triangle, 1,600 kilometers on a side. And I tell you where the vertices are. You don't really care much about that. Assuming it is flat, what is the area? Well, we have to use Heron's formula because we know the three sides, but we don't know anything else about the triangle. So we find the semi-perimeter and call that 2,400. We plug it in to Heron's formula, and all of these will be the same numbers. So that's really just cubing that, and you end up with 1,100,000 square kilometers is the unit that you should have for this. Number 6, you have the following quarter circle has a radius of 5, so that means this is 5 and this is 5. This is a quarter of the circle. What's the area of the shaded region A? So that's the area right there. Well, that's the difference between 1/4 of the circle, so that's 1/4 pi r squared, or 1/4 pi times 5 squared minus the area of the circle, but that's 5 and that's 5, so this is 1/2 5 times 5, 1/2 the base times the height. You do all that calculation and you get 7.13 square inches is the units. Number 7. This was an irregular shape problem. I gave you a drawing and you had to go through and calculate that. I basically told you to use the trapezoidal rule. You had that in your grace notes, and so you do the calculation and you get 66.8 square meters. Number 8 was a word problem. In a practice formation, a ladder extended 10 feet just reaches the bottom of a 2.5 feet high window if the foot of the ladder is 6 feet from the wall? To what length must the ladder be extended so it reaches the top of the window if the ladder remains 6 feet from the wall and cannot be moved? This is an extension ladder. So you draw a picture like this. This is 10 and that was 6. And so that means that the height had to be 8. You get that from the Pythagorean theorem. But then to reach the top of the window, that had to become plus 2.5 or 10.5. So the new length of the ladder is again found by the Pythagorean theorem, and that's 12.1, and the answer is in units of feet. A circular pool 12 meters in, and it is important that you realize this word was diameter, has a circular sitting ledge that is 0.6 meters wide around it. That means it's uniformly 0.6 meters around. What's the area of the ledge? Well, you take the area including the ledge minus the area of the pool, and you get 23.75, and the units are square meters. That tells you something about how much concrete you would have to purchase. Number 10. Here's the figure that was associated with this. You have two parking lots, A and B. A has a frontage on Main Street of 140 feet, and lot B has frontage on Main Street of 84 feet. The boundary between the lots, that's the boundary right here, is 120 feet. So you had to put all of that stuff together. Well, these are similar triangles. So if you call this side H, you say H over the sum of those two is equal to 120 over 140. And then you solve for H, and you get H is 192 feet. And so lot A is a triangle, 1/2 the base times the height, and you get that. Lot B ends up being a trapezoid, and we can use the formula for the area of a trapezoid as we do here, and we get it is 1,300 or 13,100 square feet. So these are the answers that you should have gotten for problem number 10. Problem number 11, you will find out how much paper you needed to make this paper cup, and that is area, that's surface area, and so the answer should be square inches. And this is going to be the formula for the surface area. But first we had to find the slant height, and so we had to set up these equations for the slant height. We find the slant height is 3.9357 inches, and then the surface area is going to be pi r, the radius, times the slant height, and you get it as 22.3 square inches. The last problem, number 12, was a volume problem. The answer deals with volume, but the volumes are to be converted into gallons. And so you have a hot water tank in the shape of a right circular cylinder that is here, and there's the hemisphere on top. How many gallons does the tank hold? So the volume is going to be the volume of the cylinder plus the volume of the dome. This is the volume of the cylinder from the formula that we have, and this is the volume of the dome. Note that we only take the top half of the hemisphere on the top. And also notice that the height that we're going to be using is the total height less the radius of the hemisphere. And the radius of the hemisphere was this 1.25. So there's actually quite a bit to think about as you're putting that together. But now you just plug in the numbers. That's what's happening where my pointer is, and you get this as the volume. But then we have to convert cubic feet to gallons. I gave you this conversion factor in your grace notes, and you end up with 159 gallons is the volume.